Jai Hind everyone, myself Shiwani Singhal from Applied Science and Humanities Department in Ajay Kumar Garg Engineering College is going to deliver a lecture on water and its treatment. Basically, I will cover in 3 or 4 lectures. In first lecture, we will discuss the hardness of water and some related numerical and then disadvantage. Next, I will discuss what are the techniques of water softening like geolite, lime soda, ion exchange and some related numericals. And in last, I will discuss boiler feed water and what type of problems basically arise due to hard water in boilers. The references first from engineering chemistry by Jan and Jan, engineering chemistry by Shashi Chawla, engineering chemistry by Ville India and site www.jntu.ac.in. So, before start the hardness, first I introduce what is the water and which type of impurities may be present. Water, we know that water, the formula is H2O. It has bent structure and it is formed by chemical combination of hydrogen and oxygen. Water exists in 3 forms: solid, liquid and gas. In solid state, it has cage-like structure in which the water molecules are bonded with 2 hydrogen bond and 2 covalent bond. And because of this cage type structure, when the ice melt, the density increases. So, it is the nature's most wonderful, abundant, useful compound, and it is not only essential for living beings, it is also used for various purpose like in industries, in agriculture or etc. The distribution of water on earth's surface is not even. We know that about 71% part of earth is covered with water, in which approximately 96.5% is occupied by oceans. So, only 1.5% water is available as a surface water. We can say natural water, it may be contaminated by different type of impurities, and these impurities are classified as physical impurity, chemical impurities and biological impurities. Physical impurities are related to change in color, turbidity, taste or smell. Color, ideally water should be colorless, but sometimes the color may appear due to presence of metallic substances like salts. When we take the water in a small quantity, it looks colorless, but when we see in bulk, then it looks light sky blue color, which is basically due to absorption of light at red wavelength. Now, turbidity, ideally water should be transparent, then it means when we pass the light, it should pass 100%, but sometimes due to some impurity, especially suspension particles or colloidal particles, it become turbid. Turbid means no pass, 100% light get passed. So, it may be due to this clay, silt or etc. Now, taste, ideally water should be tasteless, but sometimes that we feel that there is a bitter taste. It may be due to some minerals, it may be due to dissolved salts, and sometimes we feel some soapy taste, and which may be due to sodium carbonate. Any type of smell is always undesirable. Now, chemical impurities. Chemical impurities again, they are of 2 types, either inorganic impurities or organic impurities. Inorganic impurities again due to cations or anions. Cations means presence of Fe+2, Al+3 or we can say metallic ions, and anions are due to the presence of NO3 minus, OH minus, Cl minus, SH minus or etc. And organic impurities means presence of dyes like paints, any type of drugs, and especially we can say insecticides or pesticides. Biological impurities are basically due to presence of fungi, bacteria, pathogenic virus or etc., and which lead waterborne disease. Now, hardness. Hardness is basically the presence of salts of calcium and magnesium. In simple way, we can say, if we add some soap in water and leather doesn't produce, means hardness of the water which prevent the leathering of soap is basically this. And why the leather doesn't produce? Leather doesn't produce because of formation of insoluble precipitates of calcium and magnesium, and which is known as scum. We see that soaps are the sodium or potassium salts of higher fatty acids. If we add NaOH or KOH in a refined and stir constantly, then after some time we see that the soap get precipitate. So, this is the example of sodium stearate, and when it is added in the presence of salts, any type of salts of calcium and magnesium, then after the reaction, long chain of calcium and magnesium salts are formed, and this is insoluble like white curdy precipitate, and which is called scum. So, due to the formation of these, that is scum, leather doesn't produce. While in case of soap water, no salts are present, that is leather get produced and it consume less soap. So, this is basically due to absence of salts of calcium and magnesium. We take the soap, sodium stearate, in water, no calcium salt, no magnesium salt. So, scum doesn't produce, it means leather get produced. There are two beakers, in both beaker water is there and some soap or detergent is added. So, in beaker 1 we see that there is no leather, so it is termed as a hard water, while in second beaker leather get produced, it means it is termed as a soft water. Now, what are the reason of hard? What are the causes? So, it is clear that hardness is due to salts of calcium and magnesium. Salts means chlorides, sulphates, bicarbonates, etc. So, there may be even natural water having carbon dioxide flows over the rocks, and rocks means calcium carbonate it may contain. One example is dolomite, that is calcium carbonate and magnesium carbonate. Then these carbonates get converted into bicarbonate and which are soluble, so they get dissolved in water, so water become hard. So, reaction is CaCO3 plus H2O, carbon dioxide is there, so bicarbonate get formed. There may be another possibility, if natural water flows over the rocks having chlorides, sulphates, nitrates of calcium and magnesium, then these salts get dissolved in water, so the water get hardness. Now, types of hardness. So, basically the hardness it is of two types. First is temporary hardness and second is permanent hardness. And if we add both hardness, we get total hardness. So, temporary hardness is due to only bicarbonates of calcium and magnesium. And since bicarbonates on boiling form carbonates which are insoluble, so we can easily say that this type of hardness can be removed by boiling. When we boil the water, we see that few white precipitates they appear at the surface of the water, which can be easily filtered off. So, it means temporary hardness on boiling, that is bicarbonates on boiling form carbonates which can be easily removed. And formula of bicarbonates, calcium bicarbonate, that is CaHCO3 whole twice, and magnesium bicarbonate MgHCO3 whole twice. Now, permanent hardness. Permanent hardness is due to presence of dissolved chlorides, sulphates, nitrates of calcium, magnesium and other heavy metal. On simple language we can say, except bicarbonates, all salts of calcium and magnesium contribute in permanent hardness. Salts are, the chief salts are CaCl2, MgCl2, CaSO4 and MgSO4. And this type of hardness cannot be removed by boiling. If we want to remove this hardness, we have to adopt another method like zeolite method, like Calgon method or etc. Now, units of hardness. Before this unit, first it should be clear that the all type of expression, it means all type of concentration, it should be expressed in terms of or equivalent to calcium carbonate. Means if calcium sulphate concentration is given, but when we have to calculate hardness, then this calcium sulphate concentration should be converted equivalent to calcium carbonate. And why we take calcium carbonate? This is simple, we can say for standardization. And but why calcium carbonate? Because calcium carbonate is least soluble in water, and second its molecular weight is 100, and when we multiply or divide anything from 100, the calculation become easier. Now, unit, first unit is ppm, that is parts per million. Million means 10 to the power 6. So, simple we can say ki ppm is the 1 part of calcium carbonate equivalent hardness in 10 to the power 6, that is 1 million part of water. It means simple, 1 part this in 10 to the power 6 parts of water. Now, degree Clarke, same term, but instead of 1 million, 70,000 parts of water. So, 1 part of calcium carbonate equivalent hardness in 70,000 parts of water. And when we correlate here, when we find the relation between ppm and degree Clarke, then we get that 1 degree Clarke is equal to 1 part of CaCO3 in 70,000 part of water. And when we change it into ppm, then we get 1 ppm is equal to either here. So, 70,000 upon 10 to the power 6 degree Clarke, and we get 0.07 degree Clarke. So, this is the simple correlation ki 1 ppm is equal to 0.07 degree Clarke. So, it is the easiest way. If we want to hardness in degree Clarke, first we find in ppm and then multiplying by 0.07 we get in degree Clarke. Now, next is degree French, same language, but instead of 70,000, here we take 10 to the power 5 part of water, that is 1 part of CaCO3 equivalent hardness in 10 to the power 5 part of water. And again when we correlate this, then we get 10 to the power 5 upon 10 to the power 6, which is 1 by 10, and 1 by 10 means 0.1 degree French. Degree FR is degree French, degree CL is degree Clarke. Now, next is milligram per liter, and this milligram per liter is very useful, especially in titration, because in titration when we convert it into ppm, we know that strength is equal to Ne and the unit of strength is gram per liter. So, gram per liter can be easily converted in milligram per liter by multiplying into by 10 to the power 3, and when we find milligram per liter equivalent to calcium carbonate, it comes ppm. So, what is the milligrams per liter? Same language, but instead of 1 part we say 1 milligram of calcium carbonate in equivalent in 1 liter of water. 1 milligram means 10 to the power minus 3, 1 liter means 10 to the power 3, then it comes basically 10 to the power 6. So, 1 milligram per liter become 1 part of CaCO3 in 10 to the power 6, that is ppm. So, is equal to 1 milligram per liter. One another unit is milliequivalent per liter. Here we take, instead of milligram, milliequivalent. The molecular weight of calcium carbonate is 100, but the equivalent weight is 50. So, here 50, it comes 50, and when we correlate this, then it comes 1 by 50, that is 0.02. So, the final correlation is 1 ppm is equal to, first we find degree Clarke, that is 0.07 degree Clarke, is equal to 0.1 degree French, is equal to 1 milligram per liter, and is equal to 0.02 milliequivalent per liter. Now, hardness of soluble salt, and degree of hardness means basically the way to express the hardness, which should be in ppm. Now, since it is it has been already cleared that all concentration should be equivalent to calcium carbonate. So, if we basically find with calcium carbonate, the simplest way is hardness is equal to concentration, that is weight, which is given in milligram per liter, into multiplication factor, and this multiplication factor is molecular weight of calcium carbonate divided by molecular weight of given salt. And why basically why we take this? If suppose calcium sulphate is given now, and when we equate this calcium sulphate with calcium carbonate, then easily we can say 1 mole of calcium sulphate is equivalent to 1 mole of calcium carbonate. That is x milligram per liter, calcium sulphate will be equivalent to x into, and when we take the mole in gram, then we find molecular weight of calcium carbonate divided by molecular weight of calcium sulphate. So, basically to simplify this, molecular weight of calcium carbonate upon molecular weight of calcium sulphate, it is termed as, we take this as a multiplication factor. So, easily if magnesium carbonate is given, then we take magnesium carbonate. If calcium chloride is given, then we take calcium chloride. So, it is a simple way. Then if we multiply the concentration with multiplication factor, then we can easily get hardness, that is equivalent to calcium carbonate. But this simple formula is applicable generally with salts of calcium and magnesium, and which are the main which are the responsible for any type of hardness. But when we do the numericals, and in numericals other than calcium or magnesium salts are given, like NaCl, like Al2SO4 whole thrice. In such cases, when we equate the NaCl with calcium carbonate, then in this case we have to take 2 moles of NaCl with equivalent to calcium carbonate. In such cases, the N factor plays a role. What is the N factor? N factor easily we can say that valency of anion or cation in calcium carbonate, which is 2, divided by valency of cation and anion in given salt. In salts of calcium and magnesium, it comes to, so 2 by 2, which is equal to 1. So, no role of, generally we take 1. But in case of NaCl, here we get 2 upon 1. So, what will be the multiplication factor for NaCl? The multiplication factor will be 100 upon 2 into molecular weight of NaCl, which is 58.5. In case of Al2SO4 whole thrice, when we equate this with calcium carbonate, then Al2, Al plus 3, 2 means plus 6. So, here we take 1 by, we have to take 1 by 3. So, simplest way is we take N factor. N factor means valency of anion in calcium carbonate, which is 2, divided by valency of cation in this Al2SO4 whole thrice, which is 6, 2 by 6, it comes 1 by 3. So, it means if we want to convert Al2SO4 whole thrice equivalent to calcium carbonate, we have to take N1 by 3. So, what will be the multiplication factor for this? 100 upon 1 by 3 into molecular weight of Al2SO4 whole thrice. Basically, this type of problem, it will come in lime soda numericals or etc. But in case in numerical of hardness, generally calcium and magnesium salts are given. So, N factor is 1. So, any type of problem basically it will come. So, here we take 3 numericals. First numerical, a water sample contains let 408 milligram calcium sulphate per liter. Calculate the hardness, and it is clear that hardness is presence. Hardness is basically concentration of this salt, but equivalent to calcium carbonate. And what is the simplest way? The simplest way is hardness is equal to W. W means concentration or weight of given salt, which is 408 per milligram per liter, multiply by multiplication factor. And what is the multiplication factor? Molecular weight of calcium carbonate, which is 100, divided by molecular weight of given salt. Salt is calcium sulphate and its molecular weight is 136. 136 3 is a 408. So, it comes 300 milligram per liter equivalent to calcium carbonate, which is ppm. So, what will be the answer? 300 ppm. Now, second case, here the hardness is given. Question is, how many milligram of magnesium carbonate dissolved per liter gives 84 ppm of hardness and molecular weight is 84. Hardness is given, we have to find W, but we apply the same formula. Hardness, which is 84, is equal to weight, which we have to find, that is W, multiply by multiplication factor, and multiplication factor is molecular weight of calcium carbonate, which is 100, divided by molecular weight of given salt. And it is already discussed that in calcium or magnesium salts, no role of N factor because it comes 1. So, W this. So, answer will be 70.56 milligram per liter. Now, next numerical. In next numerical, a water sample contains following salts. There are 5 salts. First, calcium bicarbonate. Second, calcium chloride. Third, magnesium bicarbonate. Fourth, magnesium sulphate, and 5, NaCl. And we have to calculate temporary and permanent hardness and also total hardness in ppm, degree Clarke, and milliequivalent per liter. We know that if we find the hardness in ppm, then we multiplying with the 0.07 or 0.1, depends on what is the unit. We can easily convert in degree Clarke and or milliequivalent per liter or degree French, etc. What the examiner asks. So, first our aim is to convert these concentrations equivalent to calcium carbonate. For NaCl, hardness, in hardness, the basically calcium and magnesium salts plays an important role. So, NaCl, it does not produce hardness. So, no need to do calculation with NaCl. So, we will do the calculation only for these 4 salts. And calculation means equivalent to calcium carbonate, and equivalent to calcium carbonate means concentration multiplied by multiplication factor. First, due to calcium bicarbonate, concentration of calcium bicarbonate is 8.1. So, 8.1 into molecular weight of calcium carbonate, which is 100, divided by molecular weight of calcium bicarbonate, which is 162. So, which comes 5 milligram per liter. Concentration of magnesium bicarbonate is 29.2. So, with magnesium bicarbonate, 29.2 into 100 upon molecular weight of magnesium bicarbonate, which comes 146. Atomic weight of magnesium is 24, H1, C12, O16, and then 3, or when we add we get 146. So, it comes 20 milligram per liter. Third, for calcium chloride, concentration is given 11.1. So, 11.1 into 100 upon 111, and this 111 is the molecular weight of calcium chloride. So, 10 milligram per liter. Due to magnesium for magnesium sulphate, concentration is 6 into 100 upon 120. 120 is the molecular weight of magnesium sulphate, which comes 5 milligram per liter. So, these 4 value 5, 20, 10, 5, these are the concentration of given salts, but equivalent to calcium carbonate. And temporary hardness means presence of bicarbonates, that is 5 and 20, it contribute in temporary hardness, and permanent means other than bicarbonates. So, 10 and 5, it will contribute in permanent hardness. So, what will be the final answer? The final answers will be first, temporary hardness. Now, temporary hardness is equal to, due to calcium and magnesium bicarbonates, that is 5 plus 20. So, 5 plus 20, which is equal to 25 ppm. And we know that 1 ppm is equal to 0.07 degree Clarke, that is 25 into 0.07 degree Clarke, which is 175, and that is 1.75 degree Clarke. Now, in milliequivalent per liter, 1 ppm is equal to 0.02. So, 25 into 0.02 milli equivalent per liter, it means 50, that is 0.5 milli equivalent per liter. So, answer this, this and this. Same permanent hardness. So, permanent hardness due to other than bicarbonates. So, third and fourth, that is 10 plus 5. So, 15 ppm, and in degree Clarke 15 into 0.07 degree Clarke, milliequivalent per liter 15 into 0.02 milliequivalent per liter. We can multiply this and this. Now, total hardness, temporary plus permanent. So, in ppm 25 plus 15, which is 40 ppm. In degree Clarke we can add, and in degree milliequivalent per liter we can add. Now, what are the disadvantages of hard water? The main disadvantages, or we can say water is used in for domestic purpose. It is used in boilers for steam generation or used in industries. In domestic purpose, mainly used in washing, bathing, and we know that hard water, it does not produce leather, that is more, there will be more consumption of soap. Cooking, for cooking, if we add some salt, if there is a presence of any salt in water, the boiling point get elevated. It means more fuel and more time get required. Although hard water is tastier than soft water, but it may cause bad effect in our digestive system or in urinary tracts because of formation of calcium oxalate. Second, it is used in steam generation, and when we use hard water, there may be a scale and sludge formation, there may be corrosion, there may be basically castic embrittlement or etc. We will discuss this point later. In industries, water is used in various industry, like in textile industry. If hard water, we use hard water in textile industry, then precipitation, calcium, and in terms of calcium and potassium, sodium, magnesium salts, basically it adhere to the fabrics and cause problem. In sugar industry, because of sulphates, there may be a basically difficulty in bleaching as well as in crystallization of sugar. In dyeing industry, again the dissolved salts in hard water, they may react with costly dyes, form precipitates. In paper industry, calcium, magnesium and especially iron salts in water, they may affect the quality of paper. And in pharmaceutical industry, and we know that the water is a very good solvent and it is used as a solvent in for various purposes. So, hard water may cause some undesirable products while preparation of pharmaceutical products. Thank you.